divide x squared plus 2x plus 15 by x minus 3. In long division, we would have seen another type of algorithm that looks a little bit different than this. We would have had x minus 3 on the outside, and we would have written the entire polynomial as is. But with synthetic division, it is a different type of algorithm that can only be used when you are dividing by a binomial that has a degree of 1 and has a coefficient or leading coefficient of 1. So we set up on the outside of this line that looks kind of like the upside down part of the long division. We put the 3, and that is because x minus 3 equals 0 results in x equals 3. Think of this as your 0 as opposed to your factor. Now we are going to take the coefficient of each term in the polynomial and write them with a little bit of a space. Here I've made really big space just so that it is clear. Again, we are going to write everything that we're going to have some results in each of the columns, so we're going to be working down and then we're going to be working across. First step, bring down the first coefficient. Next step, multiply by, I'm going to call this our 0. Multiply by the 0 and place the product under the next coefficient. Repeat. But this time, add 3 and 2. Multiply 3 times 5. Add 15 and 15. And we get 3 numbers. Now, what do these 3 numbers mean? Well, if you can imagine that we are doing long division, when we took the x and put it into the x squared, our resulting quotient, or the first term of our quotient, would have been an x to the first power. Therefore, that means that this 1 represents 1x. And then we would have gone down and we would have taken the next one. And then we would have had some x term into some x term, which would result in a 1's term. And so this represents 5. Now, this is our remainder. And so we write a remainder over our divisor. We're only going to use the part that if you set x minus 2 equals to 0, your resulting input or your resulting solution would be 2. I'm going to call this my 0. Next, take the coefficient of each of the terms in the polynomial that you are dividing by and place them in order into this little L. This L separates your work from your 0 and also separates your resulting quotient from any math, any arithmetic that you're doing within the problem. Bring down the first coefficient. Multiply the 0 by that result. So 2 times 1 is 2. Next, add the next terms. 7 plus 2, 9. Next, multiply the result, the sum, times the 0, and place it under the next coefficient. 18, negative 2 plus 18 is 16. Now, start with the next term down. So x divided by x squared was x. That means that this has to start at x. Then this is our 1. Then this is our remainder. What to do when you have a missing term in a synthetic division? What I mean by missing term is that if we were to actually write out this polynomial we want to divide by, with all of the coefficients, we would actually have a 0x cubed. So in long division, we would have used this. In synthetic division, we're going to use this. And so, when we are working with this problem in synthetic division, with the coefficient, we use a 0 instead to have a placeholder so that we have a coefficient that represents each single one of our terms from 4 all the way down to 0. Continuing, bringing down the 1, negative 4 times 1. Now put that product underneath the 0. Add 0 and negative 4. Negative 4 times negative 4 is 16. That result, adding negative 16 and 16 is 0. Negative 4 times 0 is 0. 1. And then negative 4 times 1 is negative 4. And the result is 0. And so we have a x cubed minus 4x squared plus 1 with no remainders